All right, hello. Today I'm going to be showing you how we can simplify radicals. So here we have the value square root of 45. Now we know that the square root of 49 is equal to 7 and the square root of 36 is equal to 6. So the square root of 45 is somewhere in between there, probably pretty close to 7. However, we're not going to be approximating or identifying the actual decimal value of this radical today. We're going to be simplifying it. So what we can do is we can take this value of 45 and we can break it down into its prime factors. Now I know that 45 breaks down into 3 and 15, and then 15 can break down even further to 3 and 5. Now what a square root actually does is it asks what number times itself gives you the value underneath the radical. Well, in this case, there is not one value that does that. So what we are going to have to do is we're just going to have to factor out what we can. 3 and 3 make a pair, because 3 times 3, well, that'll give us 9. And we know the square root of 9. So what we can do is we can factor out this pair of 3's, but when we take it outside the radical, well, we're really saying the square root of 9, it's actually equal to 3. So we're only taking out one factor of 3. So this can be rewritten as 3 times the square root of 5. 5 stays under there. So that'll be our answer. Now, for 175, well, I know that 175 can break down into some multiple of 25. Well, I'll think about 25 times 4 would be 100. Well, then there's 3 more to get 75. So 25 times 7 would be our factorization. 25 could actually break down even further into 5 times 5. And there's a pair. When I try to break down 7, I can't factor that anymore into prime factors. But this is where I see a pair. And so when I factor this down, we have 7 times 25, and then 5 and 5. Well, this pair can be taken out. But the square root of 25 is just 5. So this essentially comes out of the radical as a 5. And then we are left with the square root of 7. So our answer is 5 times the square root of 7. Let's take a look at two more examples. Now 343 is kind of cool because 343 is a perfect cube. So this actually breaks down into 7 times 49, and 49 breaks down into 7 times 7. Now some people might think, oh, well, this is just equal to 7. Well, it would if we asked what is the cube root of 343, but we're asked what is the square root. So what we can do is take a pair of 7's, factor those out of the radical, and we are left with 7 times the square root of 7. And that would be the simplified version of square root of 343. 12 can be factored into 2 times 6, and 6 can be factored into 2 times 3. So now we are left with 2 times the square root of 3. Now we gotta be really careful because some students will see this and say, oh yeah, it's gonna be 4 times the square root of 3. But careful, this is actually if we had 2 factors of 4 inside. So this is kind of like saying 3 times 16 under the radical. Factoring out 16 gives us 4. So when we see those pairs, because it's a square root, we are only factoring out one of them. Now here are two kind of challenging questions. I want you to think about what you would do to answer this. Pause the video and just think for a moment. How would you rewrite these in a simplified form? Now, hopefully you paused the video and thought about that. What I'm going to do is I'm going to take this value of 10 times the square root of 96, and just like before, I'm going to break down 96. 96 can be broken down into 2 times 48, and 48 can be broken down a lot into 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So there's a lot of factors here. And then what we're going to do is we're going to find our pairs. 2 and 2, 2 and 2, and we're left with the 2 and 3. We can't factor those out. So this will become a 2, this will become a 2, and now we simplify everything. So on the outside of the radical, we have 2 times 2 times 10, or 4 times 10, or 40. And on the inside of the radical, we're left with 2 and 3. So that's 6. So our answer is 40 times the square root of 6. Likewise, with 245, the value under the radical, that could be factored. And so when we're done, whatever we factor out, we're going to have to multiply by that 9, which is already there. So I'll take 245 and I'll break it down into its prime factorization. 245 is equal to 7 times 35, and 35 is broken down into 7 times 5. Well, here I have these factors of 7. So I factor out 1, 7. 7 times 9 gives me 63, and I'm left with that 5 underneath the radical. So 63 times the square root of 5 is my final answer. Let me know if you have any questions, and thanks for watching.